Hi everyone. Chapter 3 Alkyl halide. Alkyl halide are organic molecules containing a halogen atoms X bonded to an sp3 hybridized carbon atom. Okay, the condition here is to bond the halogen chlor from bromide must have to bond to the carbon sp3 hybridized. That meaning the halogen bonded to the carbon without double bond, single bond. Okay, the carbon with saturated carbon. sp3 hybridized carbon meaning to the saturated carbon. Okay, and can be classified as the methyl halide, the halogen bonded to the carbon with 3 hydrogen, or primary. That meaning the halogen bonded to the primary carbon, or the secondary halide. That meaning the halogen bonded to the secondary carbon, and the tertiary halide, the halogen bonded to the tertiary carbon. This is the four types of the alkyl halide. And look to this example. This is the primary halide, this is the tertiary, this is the secondary halide, this is the tertiary halide, this is tertiary halide, secondary halide, primary halide. And the same system it will be used to give the name for the alkyl halide is the IUPAC system. Then the first step is to find the longest chain containing the halogen, because we have here a special group. The functional group is the halogen bonded to the longest chain, and apply the other rules for the nomenclature. Okay, and here the chloro from here it will be take the lower number, and it will be 1 2 3 4 5 6 like that, and reverse is incorrect. Then look, it will be 2 chloro because we have chlor on the carbon number 2, 5 methyl heptane. Okay, then focus here. The chlor it will be chloro, the fluor it will be fluoro, the iode it will be iodo, the brom it will be bromo. Okay, focus on this. And instead of the IUPAC system, we have another system, but it will be used just for small alkyl halide, not for the big structure. For the small structure is the common names. Common names for the alkyl halide are used only for simple alkyl halide. Okay, simple, that meaning with small structure, not big structure. To assign the common name, name all the carbon atoms. Look, name all the carbon atoms of the molecule as single alkyl halide. Okay, then the alkyl group it will be the substituent, and the parent it will be the halogen. It will be like that, reverse to the IUPAC system. Name the halogen bonded to the alkyl group. To name the halogen, change the INE, okay, for the chlorine, fluorine, bromine ending of the halogen name to the suffix ide, okay, that meaning it will be methyl chloride, methyl bromide, iodide. Okay, and then combine the names of the alkyl group and the halide, separating the words with the space. Okay, then the common name fused space, not single word, it will be space. Look, ethyl space chloride, tertiary butyl space iodide. Okay, it will be the name, it will be two parts. Then look to this example. This is a small structure. This is a slightly complex structure, big structure. Okay. Here we can use the name by using the IUPAC system or the common name, no problem. One chloro we have here, propan. One chloro, 2 methyl propan. That meaning on the carbon number 1 we have chloro. On the carbon number 2 we have methyl propan. 1, 2, 3. 3 carbon, that meaning propan. Or it will be isobutyl chloride, because this group طلبة is the isobutyl. Okay, this structure, look, it will be one ethyl we have on the carbon number 1 ethyl, on the carbon number 2 we have fluoro, it will be 1 ethyl, 2 fluoro, cyclo, this the compound is cyclopentane. Okay, cyclopentane. Okay, but if you want to use the common names, it's difficult to name this group. Any alkyl is so difficult. Okay, This the name is for difficult. That meaning too complex to use the common name. That meaning the common names it will be used just for the small structure. Okay, this is homework for you. Give the IUPAC names for each compound. Okay, that meaning you have the structure, maybe the skeletal structure or the condensed structure. Okay, no problem. And give the names. All may be reverse. I will give you the names and I want from you the structure. The physical properties of the alkyl halide are weakly polar molecules, okay, because the halogen is high electronegativity. That meaning we have polar bonds, okay. Then we have net of dipole for the molecules. They exhibit dipole interaction, okay, not the hydrogen bond, not the van der Waals. The van der Waals it will be happen in the alkyl parts, okay, but for the dipole there we have dipole interaction, okay. We have dipole here, look, partially negative, partially positive. Partially negative for the halogen because the halogen is high electronegativity, and the carbon it will be partially positive. And the alkyl halide have higher boiling point and melting point than the alkanes because the additional interaction, okay, the alkanes there is no dipole interaction, just van der Waals forces. But here we have van der Waals forces as also we have dipole interaction. For this reason the compounds need more energy to convert the solid to the liquid or the liquid to the gas, okay. For this reason it will be higher boiling point and melting point than the alkanes. And the alkyl halide is soluble in organic solvent. Look, in organic solvent. Why? Because the alkyl halide is organic compound, must be dissolved in organic solvent, okay, dissolve. And the alkyl halide is insoluble in water because this polar and this non-polar. For this reason this aqueous, this not aqueous, this organic, this inorganic. For this reason the alkyl halide don't dissolve in the water. Now preparation of the alkyl halide. First method to prepare the alkyl halide. If you don't have the alkyl halide, then we can prepare the alkyl halide from alcohol. Again, conversion alcohol to alkyl halide with HX. HX meaning acid, like HCl, like H2SO4. Okay, alcohols undergo nucleophilic substitution reactions only if the OH group for alcohol is converted to a better leaving group before nucleophilic attack. Okay, what meaning the substitution here? Meaning to remove the OH and put the halogen. Replacement the OH group, the hydroxyl group, with the halogen. Okay, now thus substitution doesn't occur when alcohol is treated with X minus. That meaning if you have alcohol and you have just the nucleophile X minus without H plus, that meaning not acidic like NaCl, then the replacement it doesn't occur. Why? Because the OH it is poor leaving group, okay, and the substitution it will be not happened. When the substitution it will be success, but the substitution does occur on intermediate alcohol with HX. If you have acid, that meaning the substitution it will be okay, no problems, and the OH group it will be converted to the H2O group, and the H2O group is good leaving group, and it will be give you alkyl halide. Now, and then again, this the nucleophile. If the nucleophile attack from this side to remove the OH it will be go out as OH minus, and the OH minus is not stable, negative charge on the weak electronegativity atom on the oxygen. That meaning this group not stable. For this reason, this group it will be attacked again to remove the halogen, and the reaction will be reversed to the starting material. For this reason, we say the OH is poor leaving group. Why poor? because not stable. Okay, not stable. And but if we convert the OH group to the H2O group with acid, then the OH group, the shape of electron, will be attack the proton, acid-base reaction. Okay, answer, this is a Bronsted base. Attack the proton, it will be take it. It will be H2O group, and the oxygen will be plus. Then if the halogen here, the minus, attack from the backside to remove the OH2 group, it will be go out as the H2O group. For this reason, the H2O group is good leaving group. Why good leaving group? Because H2O group is a stable compound, is a stable group. For this reason, the reaction, it will be happened, and there is no problem, and the replacement, it will be give you the alkyl halide. And the reaction of alcohol with HX, X, of course, it will be chlorobromide, not a fluor, because the fluor is so active, is a general method to prepare primary, secondary, and tertiary alkyl halide. Okay, if you use a primary alcohol, it will be give you what? It will give you primary alkyl halide. If you use tertiary alcohol, it will be give you tertiary alkyl halide. Okay, now this is homework. Draw the products of each reaction. This reaction with HCl give you what, and this what is the product, and this you have to write the product. And actually it is easy homework. Just replace the OH group with HCl here, and the OH with I, and the OH with Br with the halogen, and this it will be right answer for this the 3 question. But there is something here, it will be, you have to be careful about the substitution reaction of alcohol to give you the alkyl halide. There is some fact are known about the reaction between alcohol and the hydrogen halide. Okay, and the hydrogen halide and the acid. The reaction is catalyzed by acid. That meaning without acid there is no reaction. Okay, طلبة? That meaning if you replace the HBr here with NaBr or with NaCl like food salt, there is no reaction to be happen. That meaning they catalyzed with the acid. That meaning the acid it will be used as catalyst for the reaction to give you the product. Then the rearrangement of the alkyl group occur. Okay, the rearrangement maybe it will be happened for the alkyl group. Then look for this the hydroxyl group here bonded to the secondary carbon. Okay, secondary, this is secondary carbon, but the product, the Br not come to here, to be come to here. Why? Because there is rearrangement, it will be happened during the mechanism of reaction, and it will be give you different product, not the product you will be decide. Okay, it will be give you different product, and we will take this how the rearrangement it will be happen, and how you can found the right and the good product. And here be careful, except with a primary alcohol. That meaning the rearrangement it will be happen for the secondary alcohol and for the tertiary alcohol, not the primary. You can write here there is no rearrangement for the primary alcohol. Again, the facts, the reaction catalyzed by alcohol, the arrangement it will be happened. And the third one, the order of reactivity of alcohol toward HX. What meaning the order of the reactivity? Meaning the speed of reaction. Okay, it will be for the tertiary alcohol, it will be very speed. The reaction will be very speed. Maybe during 5-10 minutes it will be finished. And the secondary alcohol, then and the primary at the final, it will be has a long time for the reaction, maybe 1 hour, 2 hour, maybe 24 hour, like that. And finally just the methyl iodide, methyl bromide. For this reason the tertiary alcohol will be very active toward the substitution reaction to give the alkyl halide, and then the secondary, and then the primary, and finally the methyl groups. More substituted alcohol, why the tertiary is very active from the primary, because more substituted alcohol usually react more rapidly with HX. Okay, for this reason, for the tertiary alcohol to be very fast, and then slowly, and then more slowly for the reaction. Okay, why this is dependent on the stability of the carbocation, and we will take it inshallah for the during the mechanism study. And the second method to prepare the alkyl halide, we take it in the chapter number 2 for the alkanes, the reaction of alkanes. The alkanes can be react with the halogen during heating or light. Okay, the free radical طلبة, the free radical mechanism for this reaction. This we take it before that. That meaning substitution of the hydrogen with the halogen during free radical mechanism, and it will be give you the alkyl halide also. The third method to prepare the alkyl halide is the hydrohalogenation. Hydrohalogenation, electrophilic addition of the HX. This is the hydrohalogenation. Okay, that meaning the addition of the HX. It will be added to the double bond or to the triple bond. Okay, now the double bond here is nucleophile, or is the base. Okay, the base. Why? Before that we said for the Bronsted base, maybe it will be double bond. Why? Because the pi bond is weak bond and can be open to attack the electrophile. Okay, attack the electrophile. That meaning the electrophile, it will be added on the double bond. For this reason, it will be electrophilic addition. Okay, electrophilic addition. This is the general name for this reaction, electrophilic addition. The special name is the hydrohalogenation. Okay, the hydrohalogenation, electrophilic addition of the HX, and it will be give you alkyl halide. Also, the mechanism, it will be a study inshallah, and I will be explain the mechanism for you in the future. Now the reaction of the alkyl halide. Okay, if you have the alkyl halide, and the alkyl halide, it will be useful for what? It will be useful for any reaction. It will be can be used as a starting material for what? For any reaction, to give you any compound. Okay, like the general feature of the nucleophilic aliphatic substitution. Look, nucleophilic aliphatic substitution. That meaning we have nucleophile here, and it will be substitution on the aliphatic compound. On the aliphatic compound. This is the nucleophilic aliphatic substitution to replace the halogen with the nucleophile. Okay, to replace the halogen with the nucleophile. And there is a 3 components are necessary in any substitution reaction. Okay, for this reaction, if you have the alkyl halide and you have the nucleophile, and it will be give you product. Okay, there is a 3 important component for this reaction. Number 1, the halogen, it will be bonded to the sp3 hybridized carbon, and we have the nucleophile. That meaning we have the starting material, and also we have the nucleophile, and also we have the leaving group, and it will be give you the product. Then the important 3 component is the R, is the starting material, the alkyl group containing sp3 hybridized carbon bonded to the X. Number 2, the halogen, an atom X or a group of atoms called leaving group. That meaning the leaving group, the halogen, or maybe good leaving group. Okay, which is able to accept the electron density. Look, to accept the electron density in the carbon X. What meaning this? Meaning it will be take the negative charge or both of the 2 electrons and give you stable group. The most common leaving group are the halide anion, the halogen. Why? Because it has high electronegativity, and it will be take the negative charge for a long time. It will be stable, and also not the H2O is not stable, but it will be from the ROH2 group plus. Here it will be plus. Look, it will be plus. For this reason, it will be go out as H2O. and also the N2 in the Rn2 plus. This the Rn2 plus طلبة is this compound called diazonium salt. Okay, diazonium salts are also encountered. That meaning can be also give you the good leaving group. And here the nucleophile. The nucleophiles contain a lone pair or pi bond. Again, the lone pair of electron or pi bond, but not necessary is a negative charge. Okay, not a negative charge. Again, but not necessary as a negative charge. That meaning the nucleophile maybe it will be neutral, متعادل, or maybe it will be with a negative charge. Look to this example, the alkyl here, the alkyl halide. This is the alkyl group. Okay, this is the nucleophile with negative charge. This nucleophile it will be attacked to remove the Cl, and the Cl is leaving group. This is also a negative charge, SH. Okay, SH group minus to be replacement, attack and remove the iodine. Also here, the methoxide or CH3 with minus to be remove the Br and give you the ether. Now look here, you have alkyl halide, you can prepare alcohol. If you have alkyl halide, you can prepare the thiol compound. If you have alkyl halide, you can prepare the ether compound. Okay, that meaning it will be give you many products. And again, we said in the last slide, we said we can use the nucleophile maybe with negative charge, or maybe it will be neutral. Okay, if you have nucleophile with negative charge, there is no problem. You will put the nucleophile and remove the halogen. But if you have a neutral nucleophile, what will be happened? How the reaction it will be happened? There is additional step. Okay, there is additional step in the reaction. And here we said when a neutral nucleophile is used, the substitution product bear a positive charge. Okay, the substitution what? Product, that meaning we have a product with positive charge, and the positive charge طلبة is not stable. For this reason, we have to remove the positive charge by cancel one hydrogen. Okay, by cancel one hydrogen. Not that all atoms originally bonded to the nucleophile stay bonded to it after substitution occur. Okay, what meaning this? Meaning this the nucleophile has 3 hydrogen, yes, and the nucleophile attack to remove the Br. And you look to the product with positive charge was also the 3 hydrogen. That meaning all the atoms originally bonded to the nucleophile. That meaning this the nucleophile bonded to the 3 hydrogen. It will be stay bonded to the nucleophile. Okay, after the substitution. Now the substitution here is happened, and the Br is removed. Okay, this is the Br, but we have positive charge, and all the nucleophile, the original nucleophile bonded to the nucleophile is stay in the product. And what will be happened? The initial substitution product readily loss a proton in a bromide lauric acid base reaction. That meaning here this is the nucleophile, we have additional nucleophile in the mixture of reaction. It will be make as a base, bromide base, and it will be attack the proton. And here that both of the electron, 2 electrons, it will be converted to the nitrogen to remove the positive charge, and it will be give you the final neutral product. This is the product now without charge. Now it will be stable. Okay, طلبة, the product with charge it will be not stable. This not stable, and this it will be stable with NH4 plus, and the NH4 plus it will be removed with the Br as a salt. Okay, this NH4 it will be with the Br is a salt, like the food salt, NaCl. All this reaction are nucleophilic substitution and have the same overall result. Okay, that meaning all the result it will be the same. Okay, the same thing. Replacement of the leaving group, remove the leaving group, and by a nucleophile and put the nucleophile. Okay, remove the leaving group, put the nucleophile, and regardless of the identity or the charge of the nucleophile. Okay, and you have to be careful here about the charge on the nucleophile. If you use the neutral nucleophile or if you use the nucleophile with the negative charge. And we said before that we have three important components in the substitution reaction, and we will explain the three components one by one. Then we will take the leaving group. Okay, in the nucleophilic substitution reaction of the Rx, the carbon bond X is heterolytically cleaved. Okay, cleaved, that meaning it will be broken. It will be the bond between carbon and halogen. It will be broken not equally. Okay, that meaning both of the electron here, you can write both of the electron, this electron, two electron here, yes, the two electron, it will be go to the leaving group. This is the heterolytically cleaved. Okay, that meaning broken, but the bond, it will be broken not equally. Okay, not electron here and electron here, no, both the electron, it will be go to the halogen. This is the meaning here. And the leaving group depart with the electron, look, with the electron pair, that meaning two electron in that bond, forming X minus. Why minus? Because the two electron, it will be go out with the halogen, with the leaving group. And the more stable leaving group, the better able it is to accept an electron pair. That meaning the leaving group can be kept. Both of the electron, it will be more stable for the longer time, of course, giving rise to the following generalization. In comparing two leaving group, if you want to comparing two leaving group, the better leaving group is the weaker base. What meaning weaker base? You can write here more stable. More stable, that meaning weaker base. Okay, more stable, it will be weaker base. Now, if you replacement this RCl, RBr, Ri, ROH plus. Now, starting material, leaving group, conjugated acid. That meaning this is the starting material, this is the leaving group, this is the conjugated acid. And look to here, pKa minus 7, minus 9, minus 10, minus 10, very small, طلبة, very small pKa. Low pKa, that meaning this strong acid. Okay, why strong acid? Because the conjugated base is more stable. Okay, now anyone is more stable, the H minus or the chlor minus. Now, of course, the H, I minus or the chlor minus. Of course, the I minus is more stable from the iodine more stable from the chlor. Why? Because the size of the element, we say the size, this has big size and the chlor has a small size. When the negative charge separate on the big size, it will be more stable, good leaving group. For this reason, this it will be strong acid, low pK. Okay, this weak acid, big pK. Okay, and look to the H2O, it is just minus 1.7. Okay, that meaning the H2O here also it is a good leaving group. The H2O a good leaving group, but not like the iodine. The iodine is very good leaving group. And the brom and the chlor, finally the H2O. And these molecules don't undergo a nucleophilic substitution. This compound can be not entered to the replacement with the nucleophile. Why? Because the fluor is not the conjugated base. Look, all this is conjugated base, or the leaving group. This, the F minus, is not stable. Why? Because the fluor with the small size. Here, OH minus not stable because the O atom is low electronegativity, and the same thing for the nitrogen and the H minus and the R minus. All this not good leaving group, That meaning this compound cannot be used as starting material to undergo to the nucleophilic substitution reaction. Okay, and the equilibrium favor to the product of the nucleophile substitution when the leaving group is weaker base. That meaning if your leaving group is stable, and then the reaction it will be happen, the nucleophilic substitution it will be happen. But if you have like this compound, Okay, the leaving group not stable, and the reaction it will be not happened, and there is no any nucleophilic substitution. The second component important in the substitution reaction is the nucleophile. Okay, nucleophiles and bases are structurally similar. Why? Because all the base has a shape of electron or the negative charge. The same thing for the nucleophile. Also has negative charge or a shape of electron. That meaning the structure is the same. Both have lone pair or the pi bond, the double bond. Okay, the double bond. They differ in what they attack. Here the different. How it will be attacked. The bases just attack the protons, okay? Because acid-base reaction, base attack the proton, proton donor, proton acceptor, okay? Unshaped pair donor, unshaped pair or electron acceptor. But the nucleophiles attack other elements or other electron deficient atom, other elements with electron deficient, okay? Usually in this reaction, usually carbon. That meaning it will be attack. طلبة, you can write here partially positive carbon or positive carbon. Okay, carbon with positive charge or the carbon with partially positive charge. Here the difference. The bases attack a proton, but the nucleophile attack carbon atoms. But any carbon atoms? Electron deficient carbon atoms. Okay, look to the nucleophile. This is the nucleophile. Attack this carbon partially positive. And this the halogen partially negative. Okay, but the base here, look to the base, attack a proton. Okay, and he said here the nucleophilicity versus basicity. Although it is generally true that the strong base is the strong nucleophile, yes. Okay, strong base, that meaning the base it will be not stable. Okay, with full negative charge is strong nucleophile. Okay, nucleophile size also and the steric factor can sometimes change the relationship. That meaning also the structure of the nucleophile maybe it will be changed. This rule here for the strong base is the strong nucleophile. Okay, for the small nucleophile maybe it will be right, but for the big nucleophile, that means the structure of the nucleophile is a big size. This relationship maybe it will be changed. And here the nucleophilicity, parallel basicity in a three instance. There is a three important rule here. Number one, for two nucleophiles, if you have two nucleophiles with the same nucleophile atom, okay, the strong base is the strong nucleophile. Look, if you have OH minus and you have CH3 COO minus, both of them, this nucleophile with O minus and this nucleophile with O minus, with the same nucleophile atom. That meaning the nucleophile atom here is O minus and the nucleophile atom here also is O minus. Okay, the strong base, anyone is strong. The strong base is strong nucleophile. Okay, anyone is strong nucleophile. This or this. Okay, that meaning anyone is not stable, it will be strong base. This anyone is more stable, this or this, of course this more stable. More stable, that meaning the negative charge is separated by using resonance. Here we have resonance, okay? And it will be stable. This OH, there is no resonance. For this reason, it will be less stable. That meaning less stable conjugated, less stable base or less stable less stable base or less stable negative part, it will be stronger nucleophile. That meaning this it will be strong nucleophile and this it will be the weaker nucleophile. And he said two oxygen nucleophile is determined by comparing the pK. If you look to the pK, okay, you will be found the OH is stronger base than the nucleophile. Okay, depending on what? Depending on the stability of the nucleophile. More stable nucleophile, weak, more stable base, it will be weak nucleophile. less stable base, it will be strong nucleophile. This is the important. Number two, a negatively charged nucleophile is always stronger than the conjugated acid. Yes, of course. This the OH minus. This the negative charge nucleophile. As I say to you, what is the conjugated acid for this? You will be say we will put one hydrogen. It will be H2O. H2O neutral, متعادل. Okay, neutral and stable. For this reason, the conjugated, the negatively charged nucleophile, this the negatively charged nucleophile, it will be always it is stronger than the conjugated acid. Okay, for this reason, if you compare OH minus with the H2O, anyone is more base. This is more base, strong base meaning strong nucleophile. Okay, and this weak base, it will be weak nucleophile. Right to left across the row of the periodic table. Okay, right to left, from the right to left. The nucleophilicity increase as the basicity increase. Okay, this is nucleophile stronger than this, and the base of CH3 stronger than this. Why? Because decreasing the electronegativity. This high electronegativity, and it will be more stable than this. More stable, that meaning is the weaker nucleophile. This less stable, it will be stronger nucleophile. Okay, less stable, it will be stronger nucleophile. The final one is the steric effect and the nucleophilicity. Steric effect in Arabic meaning الإعاقة الفراغية. Okay, الإعاقة الفراغية, the steric effect and the nucleophilicity. And here the steric hindrance is a decrease in the reactivity resulting from presence of bulky groups. Bulky طلبة meaning big groups of the alkyl. This we say bulky groups at the site of the reaction. Okay, and here for example, he said here, look to the tertiary butoxide. This is the tertiary butoxide. Okay, a stronger base than the ethoxide. Okay, if I say to you stronger base of the ethoxide, you directly to say you will be say to me stronger base, it will be stronger nucleophile. Yes, you will be say this is stronger nucleophile and this is weaker nucleophile. Why? You will be said because this is strong base, this is weak base. But in the fact, this is false. This is error. Why? Because here we have the steric effect. For the bulky group here, for the big structure, okay, here we will have steric effect. What meaning this? The moving during reaction, the moving this during reaction to attack the starting material is slightly difficult. This is big structure. Okay, that meaning has slowly attraction. Okay, but here this the small part. That meaning here the steric effect is small here. Here we have big steric effect. Okay, for this reason the ethoxide, it will be stronger nucleophile. Okay, the nucleophile always, the work of nucleophile is to attack. Okay, to attack the product, to attack to attack the starting material. Okay, anyone is easy to attack. If you have anyone is easy to attraction, or anyone is easy to move or to moving during the reaction, the small part or the big part? Of course, the small part. Okay, that meaning the small molecules is easy to moving during the reaction and to attack the starting material. For this reason, the steric effect here is very, very important. And we said before that maybe the structure of the nucleophile can be effect on the nucleophilicity of the nucleophile. And the 3 CH3 group around the oxygen atom of the tertiary butoxide create steric effect, making it more difficult for this big bulky base to attack. Okay, more difficult to attack. Okay, tetravalent carbon atoms. Steric hindrance decrease the nucleophilicity. Okay, decrease. That meaning with the nucleophile, with the steric effect, that meaning the nucleophilicity, it will be decrease. Okay, not the basicity. The basicity not related with the steric effect. We just talk about the nucleophilicity. Okay, the basicity طلبة it is the properties, but the nucleophilicity it is the properties for the reaction. Okay, and decrease the nucleophilicity but not the basicity. This is very important. The steric hindrance decrease the nucleophilicity but not the basicity. I hope you understand this. It is slightly complex for understanding, but I hope you understand this. And if you have any something difficult, I will meet you on the Zoom, inshallah, and for further explanation. And here, look, this is again, this is a small part, less steric effect. This big part, more steric effect. That meaning, if we want to use this nucleophile, it will be very useful from than this because is the steric effect dependent on the structure of the nucleophile. And here the common nucleophile in organic chemistry, this is nucleophiles, and also this neutral nucleophile, all this can be used as a nucleophile in organic chemistry reaction. And I will be stop here in the mechanism of the nucleophilic substitution. That meaning the substitution it will be happened during a way. This way maybe SN1 or SN2. I will stop here, and inshallah we will take the next lecture. And keep your study, and see you later inshallah. Have a good day. Bye bye.